Hi, Mr. Wright here again. This is the third video in our series for gyro navigation. I've already added a few variables that I will need for this one, but they're already defined in the variable list. Negative turn rate limit, steer command, and speed sign. What we're going to do now is we're going to add three features to this which will make it much more usable. One, we will add the capability to go in reverse. Two is we'll add the capability to control the rate at which the robot turns. In other words, we can specify that it'll turn no faster than a pivot turn, that it has to make a sweeping turn, or we can allow it to make a point turn. Because of problems with the compiling, I'm going to introduce a variable called steer command, which we will use at this point when we get to here for steering. I had some problems with the compiler failing to compile when I made some complex arithmetic. Let's get started. I'll shrink myself down a little so you can see better. First, let's add the capability to go in reverse. So let me sneak over here. Okay, so I pulled out a command. To make this thing work going in reverse is fairly straightforward. One is I have to know that it's going in reverse. And what we will use to specify reverse is we will make the speed negative. So we will make the speed negative to specify that. If the speed is negative, I'll let you sort the math out yourself, but this value here has to be negated to make the robot turn in the correct direction to solve out the answer. So I'll drag this over. Doesn't much matter where I put it in here. And I want to say if the speed is greater than 0, then I will set my variable that specifies a sign to 1. Otherwise, I'll set it to -1. So now I have changed this value. And I want to get rid of that for the moment. I get a multiply box. I put the speed sign in and multiply it times the heading error. Now, should I choose to do it, this will run in reverse right now. So let me connect that. We'll make sure this thing compiles. I've been having an occasional problem with it for unknown reasons. It doesn't compile. So I can check that here. I'll just download it to my robot. And it compiles. So now I have it set up so it'll do reverse. I'll demonstrate that at the end, but I'm going to go ahead and add some of the other features now. Now, if I want to limit the turn, then I need to do it right here on this turn. Remember that this start moving, if I were to put a 50 in here, it will do a pivot turn. If I put 100, it will do a point turn. If I put less than 50, it'll do a sweeping turn. To control this turn, I want to limit this, how large or small this can go. So I'm going to sneak over and grab some more terms I've already pulled out. Okay, so I pulled out several things here. What I want to do is I want to limit this value. So I'm going to put in two if statements. One says if the steer command is greater than turn rate limit. Well, that's a new variable that we will set up here in just a moment. Then I set the steer command to turn rate limit. In other words, it can't get larger than this value. Likewise, if the steer command is less than the negative limit, it will set it to the negative limit. So that will limit the size of the steering command. So I'll stick this in here. Now I have to get the steering command. Before I do that, let me bring this up. Now to use this, you must initialize the turn rate limit. I've set it to 50, which would say do a point turn. Now rather than initialize this one, which is the negative of that one, I will just stick it in here so that whatever this one is, this variable turn rate lim is, the negative turn rate lim will be the negative of it. Okay, I'm going to add another factor while we're doing this, because otherwise I'll just have to redo some of this. I'm going to bring in another variable called steer command. I'm going to stick it in right here. So now I've set the steer command equal to a term which we'll talk about in a minute called gyro gain times the heading error, which I just calculated here. Then I limit steer command. I need to take out heading error and put in steer command. Now again, I did this, theoretically I should be able to do this in one command. I had trouble getting it to compile when I did it. Now I snuck in a term here on called gyro gain. That's another new variable, and that allows us to change how sensitive the robot is to an error. If I make the gain higher, then it will be a more snappy, jerky result. If I make it smaller, it will be more sluggish. Now normally you would pick this after you build your robot, depending on the wheels and other geometry, you have to pick a value. Well, we have been running by default with it at 1 because we didn't have a gain. So I'm going to set the gyro gain to 1. My robot works pretty well at 1.2 to 1.3 for the gain. If the robot is going slow, I can go somewhat higher. So now we also have to set this value in our initialization or we're liable to get in trouble. So I'll bring out another one of these. And I'm just going to set it to 1 for now, just as a general rule. Good place to start. Okay, so now I have the camera set up so that you can see what happens. You can see over on to the left of the picture what I did is I've added 3 gyro navs so you can see how these work in conjunction with one another. I have it going in reverse, so my robot right now is pointed in the wrong direction. So right now my robot is set to go backwards. I have 3 Gyro Nav Commands. The first one says for it to turn left 45 degrees going backwards for 2 rotations. Then it says go forward and turn left 45 degrees. And the final one says to turn minus 90 and back up 3 rotations. And it's going to go at a faster speed. So let me run this. All right, and so that is it. In reality, you need to do much more testing than I've shown here to make sure it works, because occasionally, unfortunately, our programs have bugs in them. Now I've set up a slightly different scenario. I want to demonstrate a problem you can have with this my block. I have the robot going 2 rotations straight ahead, then I have it stop and wait 5 seconds, then I have it come right back from the direction it came and then again stop. During this 5 seconds, I'll turn the robot. And I think what you'll see is then I don't get the result I was planning on. So there are cases where the robot will be pushing on something or some other similar thing, and it will, even though it's being told to go, say, straight ahead, it will twist slightly. That won't work so well to get out of that. That was one advantage of treating the gyro as a compass rather than just a turn measurer. We can overcome that in a couple of ways. One, we could change this angle to be heading demand. Then we would eliminate the line here where we compute heading demand, and we'd put the little red heading demand here. Now that would mean that you have to give it a heading relative to the original gyro's position, and you have to consider whether it is turned a circle yet or not. The alternate way, if you want to maintain this just to simplify your programming, is I can come over and I could take and do something like this. I'll get a minus operator. I'll put that in for angle. I'll get the angle that it's setting at the moment. And now then, whatever number I put in here will be a heading relative to the gyro. We're treating it more like a compass. I'm just going to put 0 in to demonstrate this. So now then, if I do nothing, if you look at what happens here, I have 0 minus the angle. I come over here and I tell it that the heading demand is 0 minus the turn angle plus the turn angle, so it's going to be 0. So whatever number I put here is what will wind up as a heading demand. Now what that will do is that even if the robot is twisted, this my block now will try to steer you in the direction you want it to go. So let me demonstrate that. So the robot's set up, and I'll let it run. I'm going to manually turn it. And you will notice that it came back to the 0 that I actually wanted. Now, if I hadn't done that, let me do it again. And I will take this out. Take this out. I'll put it back to what we originally had, and I'll run this again. And this time you can see what happens if I don't make that adjustment. So I think you can see the issue now. We have a couple of more videos coming. I think the next one will be a demonstration of timing and debug and a more complex run. So until the next time, have a good day. That is the end of this program, and if you want to see the remainder of the series, you can look in the Lego Classroom Navigation series on Raise Robotics, and you can see all of the videos that I've completed for this thing. So be sure and subscribe, and I'll look forward to seeing you the next time.